You are used to solving systems of linear equations, but now we're going to be dealing with nonlinear equations, which give us many more possibilities than just two lines intersecting in one point. For example, let's say we have a parabola and a line here. They may just meet in one point only. There'd be one solution to that system. If we have a parabola that's intersected with a line in this manner, it's possible that we could have two solutions. Let's take a parabola here that is intersected by an ellipse that just hits at its vertex there. Now we have 3 points of intersection between those two curves. Let's find 4 solutions. One ellipse going that way, another ellipse going that way. There are 4 solutions to that system. For 5 solutions, I probably could look at a polynomial equation like that. You see, 1, 2, 3, 4, yeah, 5 solutions there. And it's also possible to have no solution, where we have a circle and a parabola, for example, that do not intersect at all. So there's a lot of possible cases, and you've got to be very careful when you're working through these problems. So for these next 2 problems, we want to both graph the system and solve using some other algebraic method. Let's look at this first problem. We have a parabola. The negative tells us it opens downward, but it also tells us it's up 3 units to start with. So here's a parabola 3 units above the origin. Your standard parabola goes down 1 and over 1. It also goes over 2 and down 4, which gives us a couple of points there and there. So we're going to have this parabola. And then we've got y minus 2x equals 0, which can very easily be converted into y equals 2x, which intersects at the origin and goes up 2 over 1. And if I kind of backtrack here, we can see we're going to have a point of intersection down here somewhere. And I'm thinking it's going to be down there at the bottom left where they intersect. That would be the point -3, -6, and we would want to check that in both of these equations. Is -3 times 2 equal to -6? Yes. If we substitute -3 into the first equation, we square it, we get 9. -9 plus 3 makes -6. So yes, that is a solution. Sometimes we can't just eyeball it. We need to really look at what it is. Now let's solve this algebraically using substitution as they ask us. If we take this first equation and substitute it into y in the second equation, we would now have -x squared plus 3 being substituted in. Let me put that in parentheses. Minus 2x is equal to 0. So we now have an equation to work with. I'm going to rearrange this. -x squared minus 2x plus 3 equals 0. Multiply through by a -1 just so we could have the x squared be positive. So x squared plus 3x, let's try that again, plus 2x minus 3 is equal to 0. And let's factor this. X plus 3 times x minus 1 equals 0. And we get x equals -3 or x equals 1. Well, that tells us we're going to have 2 solution points. When we substitute -3 in, we already know we're going to get y equals -6. And then when you substitute 1 in for one of these variables, you're going to get y equals 2. And so over here at 1, 2, we have our second point of intersection. So we have 2 points of intersection for this system.